Welcome to today's session on solving linear inequalities with two variables. So beforehand we've looked at linear inequalities with one variable where we're just dealing with an x or y, for instance. When we're working with two variables, we're going to have obviously two variables, and we're going to be working in our examples with x and y. So what we're looking to do is use similar methods to what we do when we're solving equations with our inequalities. But we could be asked, for instance, if a coordinate is actually part of a solution. In which case we'll be given an inequality, we'll be given a coordinate, is this part of the solution? So for my example, I've got minus 2x plus y is less than 4. And I'm being asked, is 0, 1 part of the solution? I'm going to do that. I'm going to substitute in my coordinates into my inequality. So I'm going to substitute 0 in for my x, and I'm going to substitute 1 in for my y, and then I'm going to multiply it out. So minus 2 times 0 equals 0, because anything times 0 is 0, plus 1 being less than 4, which becomes 1 being less than 4. So this coordinate here is actually part of the solution because 1 is less than 4. If this ended up becoming maybe 5, 6, 7, 8, 9, 10, or even 4, because it's less than or and not equal to, then this coordinate would not be part of the solution. We can also represent inequalities and our solutions using graphs, and just plotting it in the exact same way as what we do with our linear equations, our line equations. So to do this, we're going to use two different types of line. For our strict inequalities, our less than or greater than, we're going to use a broken up line or dotted line, and anything along this line is not part of the solution. For our inclusive inequalities, we're going to use a solid line greater than or equal to, or equal to, and anything along this line is going to be part of the solution. So going to show this as an example. For my first example, I'm going to use y is less than or equal to x plus 4. So what I'm going to do, I'm going to first of all just treat this as a line equation, in which case I'm going to substitute values in for my x, find out what my values of y would be, and then draw my line going straight through the graph. Plot the points and then join it all up, drawing my line. But it's going to be a solid line because my y is less than or equal to x plus 4. I've shaded the region to the right hand side by just, if I was unsure of this, substituting in values. I'm going to show that in just 1 second. Another example, I've got 2x plus y is less than minus 1. Now I'm going to rearrange this into a similar form to what I've got above, in the same way as what I do for line equation, the old y equals mx plus c. Just so if I substitute in values for my x, I can get values for my y and draw my initial line. And then the only choice I've got is that line going to be a solid or is it going to be a broken up line? And which side of the line will I be shading in as part of my solution? So if I subtract 2x from both sides, I lose 2x from the left hand side, y stays there. So y is going to be greater than minus 2x minus 1, written in the same form as y equals mx plus c, which will create this line, and I'm going to shade the region to the right of this line. Now, like I say, if you are unsure about which region to actually shade, pick a coordinate on one side of the line that you've gone and drawn, and then substitute in the values. So I'm using 1, 1, where x equals 1, y equals 1, and I'm going to be substituting it back into this coordinate here. So y will become 1, and x will become 1. So 2 times 1, sorry, minus 2 times 1, that's negative 2. So -2, take away 1, that becomes -3. Now 1 is greater than -3, so I'm going to shade my region to the right hand side, because right here is part of my solution and it's on the right hand side of this line. Now if you're unsure about exactly what regions we can shade in, and you are a visual learner, you can use the diagrams that I've gone and created, just outlining which what type of solution you could have, which side of the line to shade in different circumstances. In which case, if you want to take a look at this longer, please pause the video now. In which case, thank you very much for watching.